I'm Steve Shakell, the Director of Global Supplier Management at Air Electronics, focused on the advanced power segment.
And I'm Keeton. I'm the Executive Vice President and General Manager here at onsemi.
Simon, thanks for joining us today here. We're in Scottsdale, Arizona, where we're looking forward to talking with you about silicon carbide and all the challenges that are facing the market and some of the exciting things happening here. So really looking forward to having that conversation with you. And the first topic we really want to address is around supply chain and what onsemi is doing to address the supply and demand gaps that are facing the silicon carbide market today.
Yeah, let's explore it a little bit, right? And I think if you look at what we're doing as onsemi for silicon carbide, we have a history already in silicon, and it's going to sound pretty familiar, and we're going to use that playbook again. So if we look at silicon, we actually make our own silicon substrates. And then we grow those boules, we make those wafers, we make the devices, and then we package the devices. And we do that in silicon. We're applying that same capability and thought process, but now to silicon carbide. So we grow our own silicon carbide, we do wafering, we do epi, we make the devices, we fabricate the devices, and then we put them in different packages, whether it's discrete or modules. So it's applying that same capability. You could say we have a history of vertical integration, and I think it's appreciated by the end customers because they know that we can guarantee supply as we have all components of that supply chain. And we also do a little bit of mix and match. So when it comes to substrates, we grow our own, and we also get substrates on the open market as well. So a blended external and internal is the approach for onsemi.
Okay. There seems like vertical integration is a strong suit. Is there other people and other manufacturers that are fully vertical integrated like onsemi is?
I think if you look at onsemi, what makes us unique, again, we're the only integrated device manufacturer that's growing our own silicon and silicon carbide substrates. On top of that, you add in the fabrication capability, and then you get to the back end in discrete and modules. And that's another area of differentiation where we have this history and a very large portfolio of power modules, both for industrial and automotive. So in a nutshell, yes, we're the only integrated device manufacturer that's fully vertically integrated today.
Wow, that's really interesting.
Oh, we're excited by it for sure.
Yes. Then from a customer perspective, are there advantages? How does the customer benefit from you being fully vertically integrated?
Sure. I think there are three particular areas that customers find interesting. Number one is the assurance of supply. Certainly is key and top of mind over the last, say, 24 months or so. That's one. We can guarantee the customer you'll have the right product at the right time because we have all elements of the supply chain versus relying on somebody external to do that. So that's one, is assurance of supply. The next comes to the quality of the device and the performance of the device. Because we have all the components of the supply chain, substrate, wafering, epi, device, and the packaging, we can tune that capability across that supply chain to give the best performance or to a particular set of characteristics that the customer is looking for. So it's going to be a more optimized solution. And then the third major aspect, which is also key and critical for our end customers, is cost. Because we have all elements of that supply chain, we're not buying off the external market and having a markup in margin when it comes to buying that product. So I think that's critically important to have that all in the supply chain. Mm-hmm. I think we talked quite a bit about the supply chain itself, and we're scaling that supply chain. One thing that has to happen, though, as we scale the supply chain, we have to look at the designers working with that product in that supply chain. What's Arrow working on when it comes to support of that design capability around this new product called silicon carbide?
Yeah, so with that, Arrow is doing a lot. One of the steps that we took is we went and expanded our FAE community, and we hired specific FAEs, or field application engineers, that are focused on advanced power. And advanced power, there's really silicon carbide is a key focus there, but it's covering everything else around silicon IGBTs, all the other products, as you mentioned before, of having both the vertical integrated supply chains for silicon and silicon carbide. So we've done that. They're dispersed globally, and they're really driving those demand creation activities and helping customers adopt this new technology. So we've done that. The second step we've done is through our company eInfochips. Mm-hmm. We've created a power COE in Swindon, United Kingdom, where they're helping customers that need additional support to actually take their product from concept all the way through the whole entire design phase and to certification and helping them create these power supplies utilizing silicon carbide.
Oh, that's great.
So we're attacking it from both the traditional sort of distribution model of helping our customers in that design side, but also with design services through info chips and the power COE.
Sounds really good.
So Simon, we've talked a lot about the vertical integration and what onsemi has to offer with that on silicon carbide. But the other side of things is the technology itself and how onsemi is differentiated there. And before you mentioned that for vertical integration, you're doing the die, but all the way to the package.
Yep.
And I think that's one area that could be really helpful from the customer's understanding is to see what onsemi is doing in terms of differentiating on the package side in addition to the silicon carbide.
Yeah, absolutely. So if we look at silicon carbide itself and just the material properties, one of the benefits is working in a higher thermal environment. So a higher temperature environment, higher switching speeds, and that's great. And you want to get the most out of the material itself. The issue is when you put it in a package, you're introducing things called parasitics as you put it into a package. And you also want to get the heat out of the package to get the maximum performance of that silicon carbide device. And so onsemi has been focused on making these packages, whether it's discrete or it's modules, to reduce those parasitic inductances and capacitances in the device itself while reducing the thermal resistivity of the device to get that heat out of the device itself. Mm-hmm. And we're doing that with things like a sintered die attach. We're doing that with a clip product versus a wire bond product, and combining these technologies together to get the maximum performance out of that silicon carbide type device. We're doing this both in discrete and module. And as an example, some of our newest devices in discrete use the top cooled discrete device, again, using clip attach and also getting the heat out, as well as our F5BP. This is a module-based solution, again, using a sintered-based solution to get that heat out and get the pure thermal performance of silicon carbide to get the best advantage to the end customer.
And then the other side of that is you have the package, but then there's a lot of customers deciding with this transition of, do I use silicon IGBTs? Do I use silicon carbide? What kind of guidance are you giving customers of when do you use one, when do you use the other? Because that's a big design consideration for them.
Yeah, absolutely. And some of it, I think we start with an approach. And our approach at onsemi is we have a very large toolkit. We have silicon carbide. Within silicon, we have rectifiers, FETs, IGBTs. In silicon carbide, we have the diodes, we have the FETs, we have the modules, we have discrete devices. And what we like to do is understand what problem are you trying to solve at the end of the day. And that could be something that's better served by a silicon-based solution or silicon carbide. It really depends on what efficiency are you trying to get to, how are you trying to reduce the size and weight of the end application, and the application should determine the right solution. And so we don't try and force a specific solution, we try and talk to a customer about what problem are you trying to solve, and that helps us guide the conversation into, is it silicon carbide or is it silicon? The choice should be at the end customer, but ultimately the application talks the loudest and will determine what should be the best approach. Now, one thing we should really talk about, and there's a hyper focus on silicon carbide, and that's great, but there's a lot of supporting componentry around that silicon carbide. I'd be really curious to hear, how does Arrow work with that to get all these complementary products around that silicon carbide device?
Yeah. That's where Arrow, we have our strength in the number of suppliers and our line card breadth that we can pull in all of these different components that go around silicon carbide, or whether it be silicon as well, right? We can use these to make sure we're pulling in the right magnetic supplier, the right current sense, the right heat sinks. We're putting all this together and we're becoming experts in how these different components connect together and are efficiently designed with each other, and helping our customers make those decisions on what to use with what. And especially as they convert to silicon carbide, all of these components are changing. So that everything's having to be considered, and they're looking for Arrow to provide that guidance. And that's where, as I mentioned before, we have those advanced power FAEs that can help them make these decisions on what magnetics should they be, what's the frequency, and so forth. So we're using those FAEs as the tools to help them make these difficult decisions on the components that go around silicon carbide.
Oh, that's a great value proposition for your customers, for sure.
Simon, so we've talked about the vertical integration of onsemi. We've talked about the different technology benefits about onsemi. Now let's dive a little bit more into the markets and
Sure.
what's driving some of those growths. We all know EV, electric vehicles, is driving the astronomically large growth for silicon carbide, but there's other industrial applications that I think are driving some additional growth. Do you mind telling me where you're seeing those additional markets and what those might be?
Sure. First, I would agree 100%. Most of the press coverage and what people know about for silicon carbide is around electrification for cars. And for good reason, right? It's a huge market when it comes to the traction inverter and onboard charger. Less known, though, is all these other supporting markets that also, in some cases, touch on the EV. Things like solar infrastructure and solar charging will need inverters as well. Things like energy storage systems will need silicon carbide. The EV charging itself will need silicon carbide. And you can think of it in a full circle where you have the car kind of at the end of the circle being charged by an EV charger that has silicon carbide, being fed by the energy storage system that has silicon carbide, being fed with electricity coming from the solar system, which uses silicon carbide. And so you have this whole industrial complex for the industrial segment itself, but it also supports EV. And so the rapid adoption of EV will push this growth on the industrial sector as well. But then if we take a look at these trends and applications, would you agree and would Arrow agree, are these the right trends? Are they the right applications? How does Arrow see it?
Yeah, so for us, we see the EV market growing very large, but for us, green infrastructure, so those applications that you mentioned of electric vehicle charging stations, the energy storage, solar, those are all the markets that we're really going after as well, and where we see that growth, and we're calling that green infrastructure. But there's additional markets that we're starting to see pop up as more emerging and that are getting enabled by silicon carbide.
Okay.
And those are going to be more like your EV toll, so your electric vertical and takeoff vehicles, your solid state circuit breakers, and various other applications that are being enabled by this silicon carbide technology. The industrial drives market today is very large and is driving most of the demand for power semiconductors. What is onsemi doing to convert this market, and do you see this market converting from silicon devices to silicon carbide?
Industrial motor drives is a huge market for onsemi. What we see today is the majority of drives are using IGBTs. However, there's a lot of innovation going into the market right now, and we see with that innovation the opportunity for customers to move from IGBT to silicon carbide. That being said, we're still doing development work in both IGBT and silicon carbide, and will help the customer make the right transition at the right time. So yes, will it happen? I do believe so. We'll be there with that large toolbox, so to help the customer make the right choice for their end application at the right time.
That's great. It seems the future is really bright for silicon carbide as EVs helping to ramp it. There's the additional markets from industrial and green infrastructure that's supporting that ramp of EV. And then if it converts the industrial market and industrial drives market to silicon carbide, it seems the future is very bright for silicon carbide.
We're extremely excited about silicon carbide and excited to be working with a partner like Arrow.
So we've talked a lot. We've gone from the vertical integration of onsemi and the different technologies from the device itself to the packaging and then covering the markets. We've covered a lot of ground. Thank you very much, Simon, and we're looking forward to seeing how onsemi continues to develop the silicon carbide market.
Thanks, Steve. It's been great having you today.